Welcome back to Coding the Sounds of Music. Explore more. How do speakers work? In this video, we'll learn about the physics behind how speakers actually change electricity into sound waves. We'll even look at some of the engineering also used to make the types of speakers that you'll find around your house, whether they're computer speakers adjacent to your computer, or a speaker next to a TV set, or a speaker connected to your stereo system. All of these speakers work the same way, and we're going to figure out how that happens. So navigate to page 1.13 using the ClickPad on your calculator. This is a cutaway of a loudspeaker. The purpose of a loudspeaker is it changes electrical energy into mechanical energy. Let's first describe what sound is. Do you remember talking about the lunch line and how if you were in the middle of a lunch line and if you tripped and fell, that you might bump into the person ahead of you and cause them to move, and they may bump into the person ahead of them and cause them to move? Think about that situation for a moment. If you were to fall in a lunch line, it's your energy that moves to the next person. You retain your position within the lunch line. You just have to stand up. But your bump, the energy of your bump, is what gets transmitted, and you may knock down a few people. Or maybe think about dominoes. When a domino falls and it's in a row, you might see that that domino falls over. It doesn't really change its position in the line, but it does transmit its energy to the adjacent domino. And what happens is that the domino at the end of the line falls over, even though the original domino stays in its original position. Or think about the wave at the sports arena. When a person stands up to initiate the wave, they quickly sit down. And although it's not really the energy that propagates, but the idea of doing a wave is what propagates, because the person just adjacent takes the cue that their neighbor just sat down, so it's time for them to stand up. They stand up, then they sit down, and then their neighbor takes the cue and says, oh, it's time for me to stand up. And if everybody is coordinated, the wave moves around the arena. And it's pretty cool to watch. Well, that's the way that sound works. So sound waves are pushes and pulls of air molecules. If a violin string is vibrating, it may push on the air molecules just in front of it, and that push gets transmitted to the next set of molecules just next to it, and so on, until all those pushes make their way to your eardrum. And then the push gets focused into your eardrum, and the molecules of air just in front of your eardrum are pushed and pulled. So it's not like the air molecules are leaving the violin string and flying across the room and hitting you in the ear. Air molecules are all staying exactly where they originally were. What's moving is that energy pulse through the air. So now that we understand a little bit about sound waves, let's look at the speaker. First thing I want to draw your attention to on the speaker is this big kind of what's called cone right here. This cone right here, notice its shape, and imagine if that were to move out and then quickly move back in. It would basically push air molecules in this direction right here. It would push them out of this cone. And so that push is that first person falling in the lunch line, or the first person standing up in the sports arena. And the push of this cone on all of the air molecules right here cause the air molecules up above the speaker to also move. But remember, it's not all the speaker, or it's not all the molecules that are moving, it's that energy pulse that's moving through them. And so if somehow we can make this cone move forward and backward, so if we can get it to push out and then push back in, so to speak, it'll sit there pushing and pulling on this big cone of air that's around the speaker. This big cone of air is like a big cylinder of air in front of the speaker that's being pushed and pulled on. Well, how do you go about doing that? Well, first off, notice that there are suspensions, so to speak, in the cone. So if you look at this cone, notice that it has kind of these curves right here, this little curve of material that's kind of like a rubber material that holds the cone in place, but they're flexible so that it can move. In addition, look at this kind of corrugated piece of material right here. Notice that it can move too. So this whole thing can move up and down. It's not held rigid. It can move because of these suspensions. The next thing that you might notice, and this is a fun thing to do if you have an old speaker, is that right down here, this is a very powerful magnet right here. This is a cutaway. But right here, this whole thing, this is a cross section of a big ring-shaped magnet. This is a very strong magnet. So if you take something that's ferrous, that's metal that's made out of iron, and hold it up close to that speaker, it'll stick because of the magnetism. So that's kind of cool. Now here's the real magic of the speaker. Inside of this ring magnet right here, notice there's this right here. And you have to look closely, but what this is, it's a bunch of very small wires that are wound around a piece of cardboard, kind of like a toilet paper holder. You think of that tube of a toilet paper holder and think of wrapping a fine wire around it. That's kind of what this is. And one end of the tube is connected to the bottom of this cone. So when the cone moves back and forth, so too does that tube. It moves back and forth. But what's neat about it is it's moving back and forth in the interior of this ring magnet right here. So this is a really special condition where you have this coil of wire that loops around in circles, and it's inside of a magnet. So what's the big deal? Well, when electricity flows in circles, it does something really cool. It makes something called an electromagnet. Maybe you've seen electromagnets before. They're, like maybe at a junkyard. You've seen maybe an electromagnet on the end of a big crane to lift up derelict cars that are in the junkyard. Or maybe you've built one out of a nail and wire. But when electricity flows in circles like that, it makes a magnet. Now, what's really interesting is that if the electricity flows in one direction, the magnetic field is aligned in a direction where this direction is north. So when the electricity flows in one direction, this is north. This way is north. And when the electricity flows in the opposite direction, the magnet reverses, and this way becomes north, right here. Now, the permanent magnet, well, it's permanent, so it doesn't change. The permanent magnet's north-south is fixed. Now, if you've ever played with magnets before, you know that like poles repel. So north and north repel, south and south repel. But a north is attracted to a south, and a south is attracted to the north. So if this ring magnet has a permanent north-south field, as the electricity moves one direction, it might repel, and when it moves the opposite direction, it might attract. Well, remember that cone is attached to this tube that has the electromagnet made on it. So as the electricity flows one direction, the cone pushes out. And if you reverse the electricity, it sucks in. And electricity can be changed very quickly, thousands of times a second. And what that does is it causes this cone to move back and forth thousands of times a second. And as it moves back and forth thousands of times a second, it sets up pushes and pulls inside of this air column between the speaker and your ear. And it's those vibrations that we call sound waves, and that's what you hear. So let's take a look at the simulation on the next page, and you can see all of this in action. Now that we've learned how a speaker works and a little bit about what sound is, now we're ready to take a look at the simulation. To do this, let's move to the next page by pressing the Control key and the click pad to the right. And here we'll basically read a summary of what we discussed in the prior video footage. So let's go forward once again, Control, click pad to the right, and here's a description of the simulation. The simulation is an example of a speaker with a 500 Hertz electrical voltage wave. Well, that's a mouthful. What's that mean? Well, first, let's talk about Hertz, Hz. Heinrich Hertz was a German physicist who discovered electromagnetic radiation, and the unit for vibrational frequency is named in honor of him, Hz. And 1 Hertz means 1 movement back and forth per second. So 500 Hertz means a movement back and forth 500 times a second. Well, what's electrical voltage? Well, electricity is nothing more than a bunch of electrons standing in line for lunch, kind of like our analogy we talked about before. There are, inside of a wire, there's a bunch of electrons all lined up, and when a voltage comes through, it makes those electrons move. And so think of a voltage wave as the person falling over in the lunch line, causing the next person to move, and so on. But in this case, instead of students waiting for lunch, it's electrons in a wire, and the energy is the voltage. And that voltage wave goes into the speaker coil. Remember, the coil is that winding of wire around the toilet paper tube. And notice that it creates an air pressure wave in front of the cone, and that as the voltage rises and falls, it creates an air pressure wave that also rises and falls, similar to those diagrams that we looked at in the previous video. So let's go to the next page, and I'm going to let you do this on your own. So you do this with me. I want you to go to the next page, press Control, click pad to the right. To run the simulation, I'll choose Menu, number 2, Run, and number 1, Run. Here you can see the voltage wave moving the speaker back and forth. Try changing the sound frequency. When you're finished, press Escape to quit. Well, this concludes our Explore More, How Does a Speaker Work? I hope that you've learned a little bit about sound and the engineering of a very clever device called a speaker, which changes electrical energy into mechanical energy. Next time you put in some earphones or turn on your TV or crank up the jams on your home music system, think about those speakers inside that are creating those pushes and pulls and how you're hearing the vibrations of those sound waves. This concludes our video. Please stay tuned for the next one, Challenge 2. I'll see you there.